Okay, so this lesson is lesson 3 in chapter 11 on measures of variation. Now let's talk about how they're different from measures of center. Remember, measures of center, or mean, median, mode, are numbers that can kind of give you the middle or center of data. A measure of center is a number that kind of represents a whole set of numbers, if you can narrow it down into one number. Now, measures of variation are different. Measures of variation are used to describe the distribution or spread of the data. In other words, you're describing how far apart the numbers are, if they're close together, if they're spread apart. So that's how measures of variation are. Now, we're talking about a quartile as one measure of variation. So we're going to go down to the real world link. And in this one, it says, James asked his classmates how many hours of TV they watch on a typical day. In number 1, it says, divide the data into 4 equal parts and draw a circle around each part. So what we're doing is we're actually dividing the data into quartiles, or quarters. So I'm going to first count how many numbers there are. There's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And if I divide 16 by 4, I get 4. So what I'm going to do is kind of just draw a circle around every 4 x's. Okay, so we just split the data into 4 equal parts, and there are 4 values in each of those groups. So we are talking about how the numbers are spread apart. We're just splitting them into quarters in that situation. Now, on this page, we have a bunch of vocabulary you're going to have to know. So in the first one, it says, quartiles are the values that divide a data set into 4 equal parts. So we just split that data into 4 equal parts. The first and third quartile are the medians of the data values less than the median and the data values greater than the median. So we've already talked about these all school year. The first quartile is the middle of the lower half of the data. The third quartile is the middle of the upper half of the data. Interquartile range, we've done that a lot already, is the distance between the first and third quartiles. In other words, Q3 minus Q1. In range, the difference between the greatest and least data values, in other words, big minus little. So let's take a look at a set of data. Now down right here, we have a bunch of numbers in least to greatest order. So median, we know a measure of center is the exact middle. And in between 3 and 4 would be 3.5. That splits the data into our lower half here in red and our upper half here in blue. Okay, so the first quartile is the middle of the lower half of the data. So if we were to find the middle of these 8 numbers, it would be right between 1 and 2. That would be quartile 1, which would be 1.5. The middle of the blue, the upper half of data would be between 6 and 7. That's Q3, quartile 3. That would be 6.5. All right, so let's go down to example 1. It says find the measures of variation for the data. So here we have our data. On to the right, we have, looks like animals and their speed, how fast they can run. First, if you go from bottom to top, they have them in least to greatest order, 1 to 70. So range, remember, big minus little. 70 minus 1 is 69. Quartiles, if you have them in least to greatest order, 1, 2, 3, 4, 5, 6 numbers, and you split your numbers in half. Here's your lower half, here's your upper half. Q1 is the middle of the lower half, 8. Q3 is the middle of the upper half, 50. So they're your quartiles. Next, interquartile range, Q3 minus Q1. So you do 50 minus 8 is 42. That's interquartile range. And range, well, we have it all written down here. The range is 69. The median is 27.5. The first quartile is 8. The third quartile is 50. And the IQR is 42. All right. Your job is going to be to do problem A. Now, here's what you got to do. A says determine the measures of variation for the data. Now, don't forget to put those in least to greatest order first. But here's what you're going to have to find. Even though median is a measure of center, I still want you to find it. Notice they found the median up here. I want you to find first quartile and the third quartile. And I want you to find the interquartile range. And I want you to find the range. Got it? All right, so your job, pause the video, find all 5 of those things. If you forget how, You can go back up and look at example 1 or rewind the video back where I was explaining them. Okay, restart it when you're done. Go. All right, let's see how you did. So I already have my 10 numbers in least to greatest order. So let's start with the median. If there's 10 numbers, first I'm going to split the numbers in half right here. I've got my lower half and I've got my upper half, 5 numbers in each. The median has got to be smack dab in the middle. It's got to be right in between 60 and 61. So if I add 60 plus 61, I get 121. Divide by 2, I get 60.5. So you should have 60.5 for your median. Now quartile 1 is going to be the middle of the lower half of the data, which is going to be 58. Remember, little, big, 58's in the middle. Quartile 3 is going to be the middle of the upper half of the data, little, big, 64. Interquartile range is going to be Q3 minus Q1, so 64 minus 58 is 6. And range is going to be big minus little, 71 minus 56, so 71 minus 56 is 15. So if you add all 5 of those, give yourself a big fat C because you found all 5 measures of variation. Okay. Next page. All outliers. You are going to have a good time with outliers here. So, an outlier, we'll read the definition, is a data value that is either much greater or much less than the median. If the data value is 1.5 times the value of the interquartile range beyond the quartiles, is an outlier. That is really hard to understand, that last sentence I read, so I will explain it. So, here's what an outlier is. It is a number that is way higher or way lower than the rest of the numbers. So I'm going to show you how to follow the math steps to find the outliers. So we're going to go through in example 2. Now this is going to be different, so we're going to write down the steps so you can watch how this one works. All right, so first off, number 2, example 2 says the ages of candidates in an election are 23, 48, 49, 55, 57, 63, and 72. Name any outliers. Now they already have them in least to greatest order. I'm going to write them down in one line because I don't like when they go on to 2 lines. So let me pause it. So I have my numbers in least to greatest order in one line, and I usually first look for a number I think is an outlier. So when I look at these numbers, you look at the ends. So 23 is quite a bit lower than the rest of the numbers, so I'm thinking that 23 could be an outlier. Now 72 isn't that much higher than the rest of the numbers. I don't think it is, but you never know. So we are going to write down our steps that are going to be finding the outliers. So step 1 says find the interquartile range. Okay, so find the interquartile range. So if you have these numbers, there are 7 numbers. 55 is the median. That means Q1 is 48, Q3 is 63. 63 minus 48 is 15. So step 1 is going to be find the IQR is 15. Step 2 is going to be multiply the interquartile range by 1.5. So this is going to be step 2 right here. And if we do 15 times 1.5, we get 22.5. Now, in step 3, this is where we set up, I call these our boundaries. We have to set up a lower boundary and an upper boundary. Anything outside of these boundaries is an outlier. So this is how we set our boundaries. Let me zoom in and write this step down. So step 3 is going to be to set our boundaries. Okay, so what we have to do is we take Q1, which was 48. So we do Q1 minus the number from step 2. Remember this 22.5? And 48 minus 22.5 is 25.5. Okay? And then we take Q3. Remember, Q3 was 63. and we add that number from step 2. So 63 plus 22.5. And if we get that, we get 85.5. These I call our boundary numbers. Now let me show you what I do with them. Okay, let me zoom out. So I set a boundary number, let's start with 25.5. Now 25.5, if I go up to my numbers here, would be right in between 23 and 48. So I'm going to draw a line right there. That's my lower boundary. Now the upper boundary number is 85.5. That would be above 72, so that would be here. Any numbers outside of those boundaries are outliers. Do you see any numbers that are outside of those boundaries? Because I do. I see 23 is outside of the boundaries. So that means the outlier is 23. Remember, I thought it would be, but I wasn't 100% sure, so I had to go through the steps here. So 23 is the outlier. Now, these steps here are what you're going to need in your graphic organizer, by the way. So make sure you test that out. Now, here's what we're going to do. We're going to try, I have those steps written down there, and the steps are in example 2. We're going to try problem B. It says the lengths and feet of various bridges are, and they give us some lengths. Name any outliers in the data set. So you have to find the interquartile range. You have to multiply that by 1.5. You have to subtract that number from Q1. You have to add that number to Q3 to set your boundaries. See if anything's outside of those boundary numbers. If you are not sure, you can do this one with me. If you think you can do it, pause it and start it. Okay, go ahead. All right, so I have the numbers in least to greatest order here to help me start out. The first thing I need to do is find interquartile range. So we're going to find the IQR. Now remember, to do that, you have to find Q3 minus Q1. So let's start with Q3. Okay, this is my middle number. So this is my lower half, and this is my upper half. So Q1 is going to be the exact middle of these two. So I actually have to add those up and divide by 2, because I have no idea what's in between 88 and 251. So I'm going to do 88 plus 251. That's 339 divided by 2 equals 169.5. So Q1 is, let me write that here, 169.5. Now, Q3, I'm going to do the same thing to here. I have to add 354, unless you're a genius and you can figure out what's the middle of those two numbers by looking at them, plus 1121. They add up to 1475. Divide by 2, and I get 737.5. So Q3 is let me put my pen on, 737.5. Now, I take 737.5 and subtract 169.5, and I get 568. So interquartile range is 568. Step 2, I'm going to take the IQR, 568, and multiply it by 1.5. So times 1.5 equals 852. Now step 3 is going to be to set my boundaries. For the lower boundary, I take Q1, 169.5, and I subtract 852. So 169.5 minus 852. And I get negative, oops, I forgot to write, minus 852. And I get a negative 682.5. That's my lower boundary. Now, for the upper boundary, I take Q3, which is 737, plus 852. Okay, so 737.5 plus 852. And I get 1589.5. This is my upper boundary. So now let's take these numbers, and I'm going to set my boundaries up right here. So the lower boundary is negative 682.5. that is going to be way lower than 88. So my lower boundary would be down here. My upper boundary is 1,589.5, which would be above 1121. So outliers are any numbers that are outside of those boundaries. Well, guess what? There is nothing down here and nothing up here. There is nothing outside of those boundaries. So for problem B, there are no outliers. Oops, I wrote that 23 in the wrong problem, so we'll just write it here. There are no outliers. None. Holy cow. I thought there would be, but that was kind of tricky. All right, so let me get rid of that and some work so I can go down and do these next problems. Okay, now in example 3, it says the table shows a set of scores on a science test in 2 different classrooms. Compare and contrast their measures of variation. So let me show you what they did. This one's a pain, I get it. In room A, you have these numbers. They found the range, big minus little, the median, the middle is 80, Q3, Q1, and interquartile range. Then for room B, they did the same thing. Range, median, Q3, Q1, IQR. And then they wrote this lovely paragraph about them. So let's read it together. It says, both classrooms have a range of 35 points. Remember that? 35, 35? But room B has an interquartile range of 21 points, while room A's interquartile range is 20 points. So remember IQR, room A, 20, room B, 21. There are slight differences in the medians as well as the third and fourth quartiles. So median 80, 81, they're only off by 1. The quartiles, 89.5, 90, they're very close. 69.5 and 69, they're very close. So that's what they mean by slight differences. So they found all the measures of variation of room A and room B and then wrote stuff about it. That's all you're doing in example 3. Now go on to the next page and you're going to do problem C. So here's what you got to do. Find the 5 things for Antelope, Montana, the 5 things for Augusta, Maine, and then write a short paragraph about them. All right, this one's going to take you about 5 minutes, guys. So give it your best shot. Restart the video when you're done. Go. All right, let's get started. So I have a nice little table set up, median, Q1, Q3, IQR, and range, Antelope, Augusta. So this says temperatures for the first half of the year are given for Antelope, Montana, and Augusta, Maine. Compare and contrast the measures of variation of the 2 cities. So I'm going to find all these measures of variation for Antelope and Augusta. And this isn't as bad as it looks because if you notice, they put the numbers in least to greatest order for you. So that makes your life easier. So let's start with Antelope. I'm going to go through them quickly, so I hope you're paying attention. In Antelope, first off, median is going to be the middle. There's 6 numbers, so we have to find the middle. Let's start here. The middle of 41, 42, and 58. So if you add those up, 42 plus 58, you get 100, and 100 divided by 2 is 50. So the median for Antelope is 50. Now for Augusta, I'm going to do the same thing. I'm going to find the middle of 41 and 53. So if I add up 41 and 53, they add up to 94, and 94 divided by 2 is 47. So there, oops, I have the highlighter on. There are my medians. Now let's talk about Q1 and Q3. So let's do Antelope. Here is your lower half. 3 numbers, 30 is the middle. Okay, let's do the upper half. 3 numbers, 70 is the middle. Interquartile range, 70 minus 30 is 40. Range, 79 minus 21 is 58. See, told you that wasn't that bad, if you know what the things are. Now, let's go through Augusta. So, Q1, lower half, here's the middle, 32. Q3, upper half, here's the middle, 66. Interquartile range, 66 minus 32 is 34. Range, big minus little, 75 minus 28 is 47. I think, let me do that again. 75, 65, 55, 40, yep, that's 47. So they are my values. Now I got to write a couple sentences about it. So let me tell you what I'm looking for first, and then I'll pause it and actually write it out. So I noticed the median for antelope was a little higher. The quartile 1, they're pretty close. These are pretty close. Interquartile range. Okay, for the most part, most of the values for antelope are higher. Has a higher median. Q1 is a little lower. Q3 is higher. IQR is higher. Range is higher. So I'm going to say something about that. How most of the variations are higher for antelope, but Q1 is a little lower. I also might say, let me see, the medians are pretty close, but the range and interquartile range for antelope are a little bit higher. So that's kind of what I'm going to go for. So you can put it in your own words. I'm going to pause it and write my answer and then restart it though. So if you're interested to see what I'm going to write. Okay, so here's what I wrote. I kind of tried to summarize what I just told you a second ago. I said most values for antelope are higher, but its quartile 1, its first quartile is lower. Remember, the first quartile is only 30 compared to 32. The medians are only 3 apart. See, 50 to 47 is only 3. But antelope's IQR and range are higher. So I was trying to say that the IQR, that's 6 higher, the range is 11 higher. I should have said maybe they were much higher. But so, there's not really a whole lot you can say. You're just kind of looking at the numbers and trying to come up with something that makes sense for it. So I hope this helped. I know it's a confusing lesson, but be ready to ask me some questions tomorrow. Thank you.